Chapter 13, Observability and Monitoring. This chapter covers logging with Spring Boot, Loki, and Fluent Bit, using health probes with Spring Boot Actuator and Kubernetes, producing metrics with Spring Boot Actuator, Prometheus, and Grafana, configuring distributed tracing with OpenTelemetry and Tempo, managing applications with Spring Boot Actuator. In the previous chapters, you learned about several patterns and technologies you can use to build secure, scalable, and resilient applications. However, we still lack visibility into the Polar Bookshop system, especially when something goes wrong. Before going to production, we should ensure our applications are observable and that the deployment platform provides all the tools needed to monitor and gain insights into the system. Monitoring involves checking the telemetry available for the application and defining alerts for known failure states. Observability goes beyond that and aims at reaching a state where we can ask arbitrary questions about the system without knowing the question in advance. The product team should ensure their applications expose relevant information, and the platform team should provide an infrastructure for consuming that information and asking questions about their operations. As you'll remember from Chapter 1, observability is one of the properties of cloud-native applications. Observability is a measure of how well we can infer the internal state of an application from its outputs. In Chapter 2, you learned about the 15-factor methodology, which contains 2 factors that help build observable applications. Factor 14 suggests treating your applications as space probes and reasoning about what kind of telemetry you'd need to monitor and control your applications remotely, such as logs, metrics, and traces. Factor 6 recommends treating logs as a stream of events rather than dealing with log files. In this chapter, you'll learn how to ensure your Spring Boot applications expose relevant information to infer their internal states, such as logs, health probes, metrics, traces, and additional valuable data regarding schema migrations and builds. I'll also show you how to use the Grafana open-source observability stack to validate the changes you'll make to your applications. However, I won't go into too many details because that's something the platform team deploys and operates. Note: the source code for the examples in this chapter is available in the Chapter 13/13 Begin and Chapter 13/13 End folders, which contain the initial and final states of the project. See this link. Section 13.1, Logging with Spring Boot, Loki, and Fluent Bit. Logs, or event logs, are discrete records of something that happened over time in a software application. They are composed of a timestamp necessary to answer the question, when did the event happen, and some information providing details about the event and its context, which lets us answer questions like, what happened at this time, which thread was processing the event, or which user tenant was in the context. During troubleshooting and debugging tasks, logs are among the essential tools we can use to reconstruct what happened at a specific point in time in a single application instance. They're usually categorized according to the type or severity of the event, such as trace, debug, info, warn, and error. It's a flexible mechanism that lets us log only the most severe events in production while still giving us the chance to change the log level temporarily during debugging. The format of a log record can vary, going from simple plain text to a more organized collection of key-value pairs to fully structured records produced in a JSON format. Traditionally, we've configured logs to be printed out in files located on the host machine, which has resulted in applications dealing with file name conventions, file rotation, and file sizes. In the cloud, we follow the 15-factor methodology, which recommends treating logs as events streamed to the standard output. Cloud-native applications stream logs and are not concerned with how they are processed or stored. This section will teach you how to add and configure logs in Spring Boot applications. Then I'll explain how logs are collected and aggregated in a cloud-native infrastructure. Finally, you'll run Fluent Bit for log collection, run Loki for log aggregation, and use Grafana to query the logs produced by your Spring Boot applications. Section 13.1.1, Logging with Spring Boot. Spring Boot comes with built-in support and auto-configuration for the most common logging frameworks, including Logback, Log4j2, Commons logging, and Java util logging. By default, Logback is used, see this link, but you can easily replace it with another library thanks to the abstraction provided by the simple logging facade for Java, SLF4j. Using the interfaces from SLF4J, www.slf4j.org, you have the freedom to change the logging library without changing your Java code. Furthermore, cloud-native applications should treat logs as events and stream them to the standard output. That's precisely what Spring Boot does out of the box. Convenient, right? Configuring logging in Spring Boot? Event logs are categorized by level with decreasing details and increasing importance. Trace, debug, info, warn, error. By default, Spring Boot logs everything from the info level up. A logger is a class that produces log events. You can set logger levels through configuration properties, with options to apply global configurations or to target specific packages or classes. For example, in Chapter 9 we set a debug logger to get more details about the circuit breakers implemented with Resilience4J in the application.yml file in the Edge Service project.
See this code?
You might need to configure multiple loggers at the same time. In that case, you can collect them in a log group and apply the configuration to the group directly. Spring Boot provides two predefined log groups, Web and SQL, but you can also define your own. For example, to better analyze the behavior of the circuit breakers defined in the Edge Service application, you could define a log group and configure a log level for both Resilience4J and Spring Cloud Circuit Breaker. In the Edge Service project, Edge Service, you can configure the new log group in the application.yml file as follows.
Listing 13.1. Configuring a group to control the circuit breaker logs.
By default, each event log provides essential information, including the date and time of the occurrence, the log level, the process identifier, PID, the name of the thread from which the event was triggered, the logger name, and the log message. If you check the application logs from a terminal that supports ANSI, the log messages will also be colored to improve readability. Figure 13.1. The logging format can be customized using the logging.pattern configuration property group.
Figure 13.1. Event logs include a timestamp, contextual information, and a message about what happened.
Note: Spring Boot provides extensive options for configuring logging to files. Since that's not useful for cloud-native applications, I won't cover it in this book. If you're interested in the subject, see the official documentation to learn more about log files. See this link. Adding logs to Spring Boot applications? Besides configuring loggers for the frameworks and libraries used in your project, you should define event logs in your code whenever applicable. How much logging is enough? It depends on the context. In general, I reckon that it's better to have too much logging than too little. I've seen many deployments that just contain changes to add more logging, while it's pretty rare to see the opposite. Thanks to the SLF4J facade, the syntax for defining new event logs in Java is the same no matter which logging library you use. A logger instance created from a logger factory. Let's see how it works by adding new log messages to the web controller in Catalog Service. In the Catalog Service project, Catalog Service, go to the Book Controller class, define a logger instance from SLF4J, and add messages to be printed out whenever a client calls the application's REST API.
Listing 13.2. Defining log events using SL4FJ.
Note: Go ahead and define new loggers and log events for all the applications composing the Polar Bookshop system wherever it makes sense. As a reference, you can look at the source code repository accompanying this book, Chapter 13/13end. The Map Diagnostic Context, MDC. You'll likely need to add common information to your log messages, such as the identifier of the currently authenticated user, the tenant for the current context, or the request URI. You could directly add that information to your log message, as you did in the previous listing, and it would work, but the data would not be structured. Instead, I prefer working with structured data. SLF4J and common logging libraries like Logback and Log4j2 support adding structured information depending on the request context, authentication tenant thread, through a tool named Mapped Diagnostic Context, MDC. If you'd like to know more about MDC, I recommend checking the official documentation for the specific logging library you're using. Now that our applications log messages as an event stream, we need to collect and store them in a central place that we can query. The following section will provide a solution to accomplish that. Section 13.1.2, Managing Logs with Loki, FluentBit, and Grafana. When you move to distributed systems like microservices and complex environments like the cloud, managing logs becomes challenging and requires a different solution than in more traditional applications. If something goes wrong, where can we find data about the failure? Traditional applications would rely on log files stored on the host machine. Cloud-native applications are deployed in dynamic environments, are replicated, and have different lifespans. We need to collect the logs from all applications running in the environment and send them to a central component where they can be aggregated, stored, and searched. There are plenty of options for managing logs in the cloud. Cloud providers have their own offerings, like Azure Monitor Logs and Google Cloud Logging. There are also many enterprise solutions available on the market such as Honeycomb, Humio, New Relic, Datadog, and Elastic. For Polar Bookshop, we'll use a solution based on the Grafana Observability Stack, grafana.com. It's composed of open-source technologies, and you can run it yourself in any environment. It's also available as a managed service, Grafana Cloud, offered by Grafana Labs. The components of the Grafana stack we'll use for managing logs are Loki for log storage and search, FluentBit for log collection and aggregation, and Grafana for log data visualization and querying. Note: which technology you use for managing logs is a platform choice and shouldn't impact the applications at all. For example, you should be able to replace the Grafana stack with Humio without making any changes to the Polar Bookshop applications. We need a log collector to fetch log messages from the standard output of all the running applications. Using the Grafana stack, you're free to choose a log collector from among several options. For the Polar Bookshop system, we'll use FluentBit, an open-source and CNCF graduated project that enables you to collect logs and metrics from multiple sources, enrich them with filters, and distribute them to any defined destination, fluentbit.io. FluentBit is a subproject of FluentD, an open-source data collector for unified logging layer, www.fluentd.org. FluentBit will collect logs from all running containers and forward them to Loki, which will store them and make them searchable. Loki is a log aggregation system designed to store and query logs from all your applications and infrastructure. See this link. Finally, Grafana will use Loki as a data source and provide log visualization features. Grafana allows you to query, visualize, alert on, and understand your telemetry, no matter where it is stored. See this link. Figure 13.2 illustrates this logging architecture.
Figure 13.2. Logging architecture for cloud-native applications based on the Grafana stack.
Let's start by running Grafana, Loki, and FluentBit as containers. In your Polar deployment project, Polar deployment, update the Docker Compose configuration, docker/dockercompose.yml, to include the new services. They are configured through files I have included in the source code repository accompanying this book, chapter 13/13, end/polar deployment/docker/observability. Copy the observability folder over the same path in your own project.
Listing 13.3. Defining containers for Grafana, Loki, and FluentBit.
Next, start all three containers with the following command.
See this code.
Thanks to the dependencies defined in Docker Compose between containers, starting Grafana will also run Loki and FluentBit. FluentBit can be configured to collect logs from different sources. For Polar Bookshop, we'll rely on the FluentD driver available in Docker to collect logs automatically from running containers. The Docker platform itself listens to the log events from each container and routes them to the specified service. In Docker, a logging driver can be configured directly on a container. For example, update the catalog service configuration in Docker Compose to use the FluentD logging driver, which will send the logs over to the FluentBit container.
Listing 13.4. Using Fluent driver to route container logs to FluentBit.
Next, package catalog service as a container image, /gradle bootbuild image, and run the application container as follows.
See this code?
Thanks to the dependencies defined in Docker Compose between containers, Keycloak and PostgreSQL will automatically be started as well. Now we're ready to test the logging setup. First, send a few requests to Catalog Service to trigger the generation of some log messages.
See this code?
Next, open a browser window, head to Grafana, localhost 3000, and use the credentials configured in Docker Compose to log in, user, password. Then select the Explore page from the left menu, choose Loki as the data source, choose Last 1 hour from the Time drop-down menu, and run the following query to search for all the logs produced by the Catalog Service container.
See this code?
The result should be similar to what you can see in Figure 13.3, showing the logs from application startup as well as the custom log messages you added to the book controller class.
Figure 13.3. In Grafana, you can browse and search log messages aggregated and stored by Loki.
When you're done testing the logging setup, stop all containers with Docker Compose down. Note: following the same approach, update the Docker Compose configuration for all the other Spring Boot applications in the Polar Bookshop system to use the FluentD logging driver and rely on FluentBit for collecting logs. As a reference, you can look at the source code repository accompanying this book, Chapter 13/13n/polar-deployment/docker. Logs provide some information about how an application behaves, but they're not enough to infer its internal state. The next section will cover how you can make applications expose more data about their health status.